Imagine you have drawn a brilliant design for a new dustpan on paper. The lines are precise and the measurements are perfect. But a drawing cannot sweep a floor. Bringing that idea into the physical world requires a strict sequential process. Think of it like preparing matoke. You must gather the fingers, peel them, wrap them in banana leaves, and finally steam them. You cannot steam the matoke before you peel it. Engineering follows a 5-step sequence: marking out, holding, cutting, bending, and joining. To transform raw pine timber into a functional wooden box, we follow a specific path, expanding the cutting and joining phases while entirely bypassing the bending step. If you try to bypass any of these active steps, say cutting before you mark out your guidelines, your pieces will be the wrong size and won't fit together. Rearranging the order simply guarantees a failed product. Once your exact guidelines are marked, that precision means nothing if the material moves. Before you touch a blade, you must immobilize the wood. A heavy mechanical bench vise is a non-negotiable tool here, ensuring the timber stays perfectly still for an accurate cut. With the wood clamped tight, you can begin severing the material. Using a hand tool like a tenon saw requires long, smooth strokes. You want to let the sharp teeth of the blade do the actual work of slicing through the wood fibers. A common and dangerous misconception is that applying heavy downward physical pressure will force the saw to cut faster. This cross-section diagram illustrates what actually happens when you force it. The downward pressure causes the saw blade to bind in the grain. It buckles and inevitably slips, which ruins the material and puts your hands at serious risk of injury. Successful cutting is a matter of controlled rhythm and tool geometry, not brute human strength. While wood is rigid and requires cutting, other designs use pliable materials like sheet metal. Creating 3-dimensional structures out of thin steel requires applying localized force to fold the material without snapping it. If you strike soft sheet metal with a hardened steel hammer, you create distorted stress waves that stretch and severely dent your material. To achieve a clean 90-degree fold, you must use a tool that is softer than the metal itself, like a wooden mallet, which distributes the force evenly. Once all your pieces are cut or folded, you reach assembly. This decision tree divides joining methods into 2 categories based entirely on the intended lifespan of the product. On one side, permanent joins like wood glue, welding, and nails. On the other, temporary joins like screws and bolts. Let's test this logic. Suppose you are building a wooden bookshelf, but you know it must be completely disassembled and moved to a new house next year. Looking at these 4 options, nails, wood glue, welding, or screws, which joining method must you use? You have to select screws. Screws and bolts rely on threaded friction, which allows for non-destructive disassembly whenever you need to take the product apart. Deeply understanding how materials behave over their life cycle dictates exactly how a designer connects them, whether they rely on chemical adhesion, brute friction, or threaded mechanics to hold their creations together. Returning to our wooden storage box, we have executed the proper sequence. By precisely marking our measurements, clamping the pine securely in the vise, and using smooth saw strokes, we have produced perfectly sized individual panels. Because this box is meant to stay together permanently, we apply wood glue to the edges for a strong chemical bond. We then hammer nails into those joints to mechanically lock the pieces tightly together while the adhesive cures. Looking back at our operational workflow, every hand tool in a workshop maps directly to a specific phase. The pencil belongs to marking out. The bench vise handles holding. The tenon saw tackles cutting. The mallet manages bending. And your glue and nails complete the joining step. The final phase is finishing. By sanding rough edges and applying polish, those joined pieces are elevated into a refined, usable product. Great ideas are useless if they remain trapped on a page. By mastering this strict physical sequence, you develop the capability to physically build the world around you.